We are going to create some histograms, which is another type of quantitative data graph. Now this is going to look very similar to a bar graph, but there are some very major differences between a histogram and a bar graph. First of all, histograms are quantitative as opposed to qualitative. Bar graphs are qualitative. If I was going to include team name as one of our data points, then I would have to use a qualitative graph. I could use a bar graph. But because I want to create a quantitative graph, I'm only going to use one of these data points. So we have team name, we have wins, we have at-bats. Those are all three are different data points. I'm just going to focus on the wins here. So I'm going to highlight the wins column. I'm going to go to my insert ribbon. I'm going to go back to my statistics tab, and I'm going to choose the histogram. And Excel will automatically create a histogram. And what you can see about this as opposed to the bar graph is that the bars are touching. And that's because this horizontal axis is actually continuous. So this goes all the way up to 68, includes 68. And then this starts at 68.00001. Now, for baseball, we go from 68 to 69 wins. We don't have fractions of a win, but this is starting right above 68 and going all the way to 84, including 84. And then this picks up a little bit bigger than 84, goes to 100, including 100. And then this one picks up right above 100 and goes to 116, includes 116. Now, Excel makes histograms a little bit different than you might see them in other places with this format along the bottom. Usually we include everything up until this bottom value. And then this is what includes it. And then this is the open bracket. And then this one's closed. And then this one's open. This one's closed. And that one's open. It doesn't matter. In the end, we're going to get the same information. So a couple things that I want to do here is, again, I need a chart title. This is going to be wins by MLB teams in 2021. I happen to know that because I got the data. I also want to add a horizontal and a vertical axis title. This is the number of wins, and this is the number of teams that got those wins. So there were 6 teams that got between 52 and 68 wins, and there were 11 teams that got between 68 and 84 wins, according to this, not including 68, so 69 and 84. And this one is 85 to 100, and this one is 101 to 116. There were only 2 teams that got between 102 or 101 and 116 wins. Okay. Now, Excel, I don't know what the program is doing to decide what these intervals are, but sometimes they don't always do a great job. So if you click on, let's say that window wasn't open and you're on your chart, you can double click on the bar. I think on Windows you have to double click on the values along the horizontal axis. Actually, I have to do that here. I'm going to double click on the horizontal axis, and then I get this option for the bars. And in there, I can decide, I need to click on the bars. I'm sorry. Click on the bars. I get this menu. And right now, it's automatically creating these bins, which normally are called classes. But each bin or class is a certain width, and they're all the same width. And this is just done automatically. Now, if you wanted to, you could say, well, I just want to make sure all my classes have a width of 10. And you can put that number in, and Excel will automatically change according to what you're putting in there. You could say, well, okay, I don't care what the width is. I just care the number of bins, and I can do 6 or 7 or 8, or I can go down and do less. Okay. I'm actually going to stick, though, with the bin width being 10. So why not? All right. So that's if I have the original data. This is all the original data right here in this column. I can just highlight that and insert my histogram. And there it is. But sometimes I'm not given the data, the original data. Instead, I'm given a summary of the data like I have here. Okay. And here I have my lower class limit and upper class limit. So this is the lower boundary of starting at the min, going over, and the class width is 10 because I'm taking the range of this data set and dividing it into 6 equal classes. It comes out to 9 point something. You round up to 10. And so that means the distance between all the lower class limits should be 10 and the upper class limits should be 10, which means the midpoint of each class boundary is also here, and those are separated by 10 as well. So there are 4 values that fall between 52 and 61. There are 3 values that fall between 62 and 71. There are 8 values that fall between 72 and 81, and so on and so forth. Okay. This is also a good time to introduce relative frequency. I don't necessarily know if 4 is a large number until I compare it to the sample size. In this case, it's actually a population because it's all the teams in the MLB. But 4 compared to 30 is 13%. Is that a big number? Not really. There were 8 teams that had between 72 and 81 wins, and that was 27% of the league. So that's a bigger percentage. And so that relative frequency tells me that compared to the larger group, the overall group, how big each of these classes are. And then we have cumulative frequency, which adds as you go along. And if you're following along on the provided spreadsheet, you can look at the formulas here that I created to do this, but you're not going to have to create this yourself. All I want to say is that if you're given the original data, you're going to use the built-in histogram feature. If you're given grouped data, you're going to use a different method to create a histogram. So I'm going to create a histogram that's centered on the midpoints instead of giving the ranges here, because I can't do that. I can't highlight both of these columns and then the frequency. Excel won't understand that. But I can choose the midpoint and the frequency. So this is going to sound strange, but in order to do this, I'm going to go to my Insert ribbon, and I'm going to create a scatter plot first. And what this scatter plot is actually doing is it's saying that this 56.5 is tied to this 4. It's an ordered pair. Okay, and this 66.5 is tied to this 3. So it sort of groups the data together. It actually ties them together, which is what we need. Otherwise, if I just went straight to a bar graph, a column graph, it thinks each data set should be graphed separately, and we don't want that. So what we're going to do instead is we're going to insert a scatter plot that links the 2 data points together, and then I can change the chart type to a column graph. Now this looks like a bar graph, and I said previously that the bars should be touching because the horizontal axis is continuous, which is true. So I'm going to double click on my bar, and you can see I can change the gap width to 0. If you like that little space that Excel puts in between the bars, you can actually do to 1%, and you got a little space here. Now look at these 2 graphs. They're not exactly the same, but they give us the same overall shape idea of the data. And we can see that they're actually not exactly the same when we go to do data labels. But first I'm gonna highlight this. I want to add, again, axis titles. We always want axis titles so that our reader knows what we're doing. Again, this is wins by MLB teams in 2021. This is the number of teams. And this is the number of wins. So I'm also going to add some data labels right above the bars, outside end, and then we're going to see the difference here, outside end. So you can see that this built-in histogram gives us 9 in this middle bar, and then 8, and then 4, and this is 8, 7, and 6. And the reason for that is you can see our boundaries are slightly different. Excuse me. You can see this one includes 82, which as on ours, like the 62 is the beginning of the next class, whereas the 61, so this one's including a 62, where this one's not. But there just doesn't happen to be any 62s that contradict or conflict there. Same thing here with the 3. They both have 3 within that range. But here, there were several values that were that must have been 82, or there was one value that was an 82. This one included it, and this one did not, and instead it put it in this one. But then there was also a value. There must have been 2 values that were a 92 that got included here for the 6, because the 92 didn't start until here, and the original histogram included it there. Again, it's not a big difference because when we look at the overall shape of these graphs, the overall shape is almost identical, and that's all we're really looking for when we create these. So that's creating a histogram with the built-in feature, much easier, much faster. And then if you were given group data, create the scatter plot, and change it to a bar graph. We can quickly create another histogram, built-in histogram feature. This is number of at-bats. And I just want to compare that with the box and whisker plot for the same data. We're going to do the same data. We're going to insert box and whisker plot. Again, the box and whisker plot never comes out good to begin with, so we're going to just want to make sure that we change the boundaries. So it looks like 5,000 is way too low. I can do 5,200 for my lower bound. I can do, it looks like 5,600 for my upper bound, and I think we still have all the data showing. All right, again, we don't need that. So this box and whisker plot not only has a box and 2 whiskers, but it has 2 dots. And the dots here are outliers. We're going to talk in the future about how do we identify outliers. But this box plot breaks down the data into 4 quartiles. And so we have our bottom 25% here, percentile. Then we have our bottom mid, the next 25 percentile. That brings us to our 50th percentile. Then we have our 75th percentile here, and then this includes the upper 25th percentile. So this point right here would be the 100th percentile because it's the largest one. I would take the time to label these, but I have to keep these videos under 15 minutes, otherwise YouTube kicks me out. I'll catch you in the next one.